As part of the Artemis mission, there's campaign, there's likely going to be lots of rover technology needs. And so the slope lab here behind me is a way to evaluate the performance of these vehicles in a controlled environment so we can assess their ability to climb slopes, traverse rocks, get out of stuck situations, drive through some really sticky soil like this, which is unique because you typically can't do these sorts of tests outdoors. Everyone's heard of Apollo program back in the 1960s and 70s. This was NASA's basically first mission to get people to the surface of the moon. Artemis wants to take it a step further. We want to bring people back to the moon, but we want to figure out how to live there and do science there. So it's basically having a sustained presence, not staying there for a couple days or a couple weeks, but basically living there for months, if not years. Learning a lot about the history of the moon and Earth, and then figuring out how to live there tells us how we can live eventually on Mars, which is the next step. So yeah, Glenn's role is going to be very big when it comes to Artemis, and I couldn't even tell you all the things they're doing, but I know beyond just rover technology, we have a big ISRU presence here, in situ resource utilization. So if we're going to go to the South Pole of the moon and extract resources, we got to figure out how to do that. How do you dig them up? How do you convert them into oxygen and fuel and water? And so we have teams here working on that. We have lots of power research going on here, figuring out power sources and batteries that can be used on these sorts of missions. Communication is a big challenge. We're going to be setting up basically a gateway program. It's like a space station that goes around the moon, and so there's lots of folks here working on it as well. And then even propulsion too. We're going to be sending large masses to the surface of the moon and eventually Mars. You need to figure out how to launch those things into space. And so these are all things that Glenn's going to have a hand in. That's a really good question. Why to go to space and the moon and Mars? And there's lots of answers to it, I guess. One, we learn a lot about the Earth's and the universe's history by going to the moon and Mars. There's things on those bodies that are preserved in time that we don't have here on Earth. We have lots of weathering going on. And so you can't go to a spot on Earth and see, okay, what did this look like a billion years ago? You can do that on the moon and Mars. We can potentially look for resources that we can potentially use at some point if we're going to do further deep space exploration. It's a lot easier to launch from the moon to Mars than it is from Earth to Mars. And so if you can use the resources there, that helps us explore further out into the solar system. Also look for life. We believe that there was life. We believe there's likely life. There's certainly evidence of former life on Mars, and if we can find proof of either former or existing life, then that would just be groundbreaking all around it. It kind of reshapes how we think about the universe. And I think just the inspiration I think it draws too, and that was a big part of the Apollo program, was going there and inspiring generations of people to think we can actually go to the moon, and think the next generation, okay, we can get to Mars and live there. What's next? So it really drives up the science and the engineering fields to take things take things a step further. Spinning off space technology and using it here on Earth is a big benefit of NASA as well. We saw the tires, these were developed for rovers in space, but you start seeing how they can be used here on Earth to revolutionize the auto industry, use them on aircraft tires, off-road vehicles, things like that, and starts really opening up other big benefits on Earth too.